Hello everyone, today we're taking a look at page 45. We're going to start solving some trig functions today. So what's important about solving these trig functions is when we have equations of trigonometry, we need to recognize that there could be multiple answers. Sometimes we're going to see answers repeat, but likewise there's going to be situations where sometimes we don't have any solutions. It just depends on what interval they're giving us our question on. So let's talk about what that means. I'm going to draw a graph right here. It asks us to graph a sine function below. So we know sine starts at 0. And what happens is as we move across our flow of sine, it takes 2 pi is one entire period of sine. Meaning at pi over 2, it's going to reach positive 1. At pi, it's going to go back to 0. At 3 pi over 2, it goes to negative 1. And at 2 pi, it goes to 0. And it would continue to repeat that into infinity, causing us to have lots of answers. But what we're really concerned about here is the question says, give the solutions to the equation when sine of x equals 1/2. Well, we have 1/2 right here. That's this part of this circle. So I know that any time that goes through the 1/2 spot is when sine would equal 1/2. So there's two instances of that, right here and right here. And again, those are kind of rough estimates because I obviously sketched that graph by hand. But those are two spots where that solution comes up to 0.5. In fact, we could get that answer by thinking about on the unit circle, when does sine give us 1/2? And we know that happens at pi over 6. So I know it's kind of hard to see on here, but that really represents pi over 6. But it would also represent 5 pi over 6 because sine is also positive in the second quadrant. So I know that this would happen when x is pi over 6 and when x equals 5 pi over 6. Again, I'm just thinking about my unit circle in that case. When does the unit circle give us 1/2 for the y value? Well, again, we see that on the graph, that happens at pi over 6 and 5 pi over 6, but it also happens on the unit circle at those. So you could check on the unit circle and see when that y coordinate pops up. And here's where it gets a little bit tricky. Notice that this was the interval 0 to 2 pi, meaning only on this curve when do we get 1/2. So we see 2 times. What happens if they ask about going to infinity, though? If you have to find all the answers to infinity, then you have to be more aware of the fact that this will continue to repeat itself over and over. We know that tangent repeats itself every 2 pi. In other words, the first answer is no longer just going to be pi over 6. It's going to be pi over 6 plus or minus 2 pi k times. Meaning 2 pi can happen as many times you want. You can add 2 pi 7 times. You can subtract 2 pi 6 times. However you do it, adding or subtracting 2 pi will give you an answer that also works because the unit circle is going to repeat itself. Likewise, that also makes an answer over here. X can be equal to 5 pi over 6 with the exact same conditions. If I add or subtract 2 pi any k number of times, you're going to get an answer that comes up to 1/2 again. So being mindful of how they're asking, what interval they're asking you to look on is very important. So let's take a look at this first one here. Example 1 says we have 5 cosine of the x plus the square root of 2 equals 3 cosine of x. And they want us to find it on the interval negative infinity to infinity. The major difference that's happening between how you've been solving equations and how we're going to solve equations in trig is the fact that instead of just using x, now I've got cosine of x. So that's my variable. Cosine of x is my variable. And I need these two variables to go together with each other. So I need to get all the cosines onto one side. So what I'm going to do is I'm going to subtract 3 cosine of x from both sides. Just like with our variables, what would happen is that this 3 cosine of x and minus 3 cosine of x are going to cancel. Here I've got 5 cosine of x minus 3 cosine of x, so I'm going to be with 2 cosine of x. Bring down my plus the square root of 2 and equals 0 once I've moved everything over. Next, I'm going to go ahead and subtract this square root of 2 from both sides. That's going to cancel out here, so positive square root of 2 and negative square root of 2 are going to cancel. I bring down my 2 cosine of x equals negative square root of 2. And one more step here is to divide the 2 out from in front of this cosine of x. So ultimately, I end up with cosine of x equals negative square root of 2 over 2. Now, because they asked us to find this on the interval of negative infinity to infinity, we want to think about cosine entirely on the circle. Where does it go on the entire unit circle? Being that cosine is the x value and we're getting a negative cosine here, I know that this has to come from the left side of the unit circle, meaning quadrant 3 and quadrant 4. So where does cosine give us square root of 2 over 2 in quadrants 3 and 4? Well, I know that in quadrant 3, it's going to be at the pi over 4 spot. It's at those 45-degree angle spots. So it's going to be at 5 pi over 4 in quadrant 3. And in quadrant 4, it's going to be at 7 pi over 4. But again, being very, very cognizant of the fact that this could go to infinity means I have to add something to the end of these, plus or minus that piece that we talked about earlier, 2 pi any k number of times. So you've got to put that whenever it's talking about infinity to represent that we have an infinite number of solutions anytime we add or subtract 2 pi. Using that same question over here, same idea, we've got 6 sine of x minus the square root of 3 plus 4 sine of x, again, on any interval. So starting us off, let's get our sines isolated to a single side. So we'll subtract this 4 sine of x. Get rid of the smaller one to keep things kind of looking nice. So 4 sine of x and negative 4 sine of x are going to cancel. Here I've got 6. There we go. 6 minus 4 is going to be 2 sine of x. Bring down this. Ooh, where'd that go? Try that again. Bring down this minus the square root of 3. And over here that canceled, so I just have 0. All right, we'll add this square root of 3 to the other side. This is going to cancel here. And I end up with 2 sine x equals 0 plus the square root of 3. So just, what is happening? Keeps jumping on me. Equals square root of 3. In that next step, then I'm going to need to divide by 2 to cancel out these 2's. And I get sine of x equals the square root of 3 over 2. So sine is always the y value. So when does the y value give us the square root of 3 over 2? And I know that's going to happen at pi over 3 in quadrant 1. But seeing as sine is positive in 1 and 2, I know that I also need the pi over 3 in quadrant 2, which is 2 pi over 3. And again, making note, because we go to infinity, we're going to put plus or minus 2 pi k on the end. And those are our solutions for this one. All right, in example 2. Example 2 says solve the values of x on this trig function. I've got this crazy looking tangent thing that's got stuff on both sides. So starting this off, first thing I know I got to do is I got to get all the tangents onto one side. So I've got this negative 3 tangent. I want to add that to bring it over. So I'll add 3 tangent, that cancels and that cancels. And I end up with 6 tangent of theta plus 2 square roots of 3 equals 8 square roots of 3. And again, that canceled. So now I can move the square root of 3. And since they're both square root of 3, you could just subtract it like normal. You don't have to do anything extra here because they both have the same radical at the end, the same square root at the end. So my 2 square root of 3's cancel. And I end up with 6 tangent of theta equals 8 minus 2 is 6, and that square root of 3 kind of acts like a variable. It's still going to be 6 square roots of 3. And our last step that we could do in solving this and getting it by itself is dividing both sides by 6. Those 6's cancel, and actually it's going to cause the other 6's to cancel too as well. So really this becomes 6 square root of 3 over 6. The 6's go away, and it just becomes tangent equals the square root of 3. So again, asking ourselves, when does tangent give us the square root of 3 as an answer? Here's the nice thing with tangent. With tangent, because the first quadrant repeats itself in the third quadrant and the second repeats itself in the fourth, it goes in a pattern. It goes positive, negative, positive, negative, positive, negative, positive, negative, positive, negative, positive, negative. Whereas something like cosine doesn't do that, because cosine is the x value. It goes positive, negative, negative, positive, positive, negative, negative, positive. Cosine doesn't do this nice pattern like tangent. So with tangent, you don't have to find all the answers. Tangent, you're only ever going to find your answers in these top 2 quadrants or these right 2 quadrants. I think for many of us, it'll be easier to think about it as these right 2 because it fits into our intervals of tangent. So when does tangent give us positive square root of 3? Well, we know that's going to happen in quadrant 1. Again, we are kind of disregarding all of this over here. We know it's going to happen in quadrant 1 because that's where it's positive at. And since it's the y divided by the x, I know that it's going to happen. It's supposed to be tangent, or sorry, theta. It happens at pi over 3. But since the period of tangent is not 2 pi, we just pointed out it's only 1 pi, you're not going to put plus 2 pi k for tangent. You're just going to put plus pi k for tangent. So sine and cosine, you put 2 pi k at the end. But for tangent, you just put plus pi k, and you only put the one answer in. All right, coming in on the bottom down here, we've got these sine squared u plus 8 equals 11. And you'll notice that this one has an interval that's not negative infinity to infinity. So we're going to have to work a little bit differently here. There's a couple new things that we got to look at. Firstly, let's get this equation solved. We got to get a sine by itself, so we're going to get rid of that 8 on both sides. I end up with 4 sine squared of u equals 11 minus 8, which is 3. And then we're going to need to divide this side by 4. Divide this side by 4. Cancel. I don't know why I didn't switch colors. Now we get sine squared of u equals 3/4. And I got one more step. Because it's sine squared, we're going to square root both sides. Now, when I square root a fraction, the easiest way to think about it is square root the top and the bottom separately. They each get square rooted on their own accord. So over here, the sine squared and the square root cancel, so I just have sine of u. On that right side, the square root of 3 can't be simplified, but square root of 4 does and becomes just 2. So I end up with square root of 3 over 2. So we have to ask ourselves, when does sine equal square root of 3 over 2? But I can only pick answers between pi and 3 pi over 2. In other words, I'm only using quadrant 3 because pi is right here and 3 pi over 2 is right here. So I'm only using these answers here. Well, is sine even positive there? Considering sine is the y-coordinate are not positive here. So I can tell you right from this, we would have to say no solution because it is not positive in the third quadrant. So no solution because it doesn't come out to be a positive. Now, does square root of 3 over 2 exist for the sine? Absolutely. It happens at pi over 3. And because it's the y, it also happens at 2 pi over 3. But neither of those are between pi and 3 pi over 2, so we can't choose those answers. Part B says 4 times the cosine squared plus 5 equals 7, and we're finding it from pi over 2 to pi. Let's talk real quick about where that's at, just so we have it in our mind. We know that pi over 2 to pi is going to represent this quadrant here, the second one. Pi over 2 is going straight up, pi is going to the left, so it's going to be somewhere in that quadrant if the answer works. Solving this then, subtract the 5 so we can get this cosine by itself. So we're going to bring down our 4 times cosine squared equals 7 minus 5, which is 2. And we'll divide this side and this side by that leading coefficient of 4. We get cosine squared of x equals 2/4, which is the same thing as 1/2. Actually, let's not do that. Let's not simplify it. Let's leave it as 2 over 4. Don't simplify till the end because you're going to see right here, we need to square root both sides right here. So when I square root it, it's going to come out a little bit nicer. Cosine of x equals the square root of 2 over 4. The square root of 4 is 2. So square root of 2 over 2. So we can see that that's an answer that makes some sense. Being that cosine is our x value, in this case, would the x ever be positive in quadrant 2? No. So I have another situation where we would have to say no solution because quadrant 2 can never have a positive version of cosine, and that's what they're trying to get us to get here. So no solution. Oh, that brings us to the end of those. So if you have any more questions, please let me know.